Morning. I'm using the mic so I can save my voice because I have a fairly long presentation over the course of several days. I think, transitioning from the sources section, we're all in different stages of our solar car building. Some of you guys are here to try to collect information in preparation for building a car. Some people have started doing some prototyping and examples. Some people have cars that they're updating, and so you're all in different phases. What we want to do is we want to go through the basics of how you actually build a solar car, the materials that you might use, things like that. And while I have a prepared presentation, I do welcome, especially teams who have been here, who've done this stuff, who have examples and stories to chime up and make this more of a collaborative presentation. Okay, first off, we do want to have a little discussion on the divisions, just so that we sort of lay a context for what we're trying to build. So in this race, we have 4 divisions. We have the Classic, the Veteran Classic, the Advanced, and the Solar Electric. So in the Classic division, this is what's meant to be our entry-level division. So if you're starting a new team, that's where you want to be. Why do we want you there? We've limited some of the technologies to the solar cells, the no-hub motors, lead-acid batteries. These things are meant for you to limit the cost, right? Solar cells that get into the 1920s, and above, you're talking about a lot more expensive cells. Hub motors, you can't really buy the NGM hub motors anymore unless secondhand, but there is the other hub motor. Remind me what it is? Mitsuba. What is that now? 25K.
The motor and the controller are 18.
Yeah, so we're talking about, you could probably build a Classic division car for the cost of a hub motor and controller. So that's why this is really meant to be an entry-level division. You can see the champion of the last year in the Classic division. The type of car that you have is a lot of Classic division cars has this array over body type of shape to maximize your surface area of the solar panel. Jen.
On the top bullet for solar cells, less than 18%.
Sorry, it's a 19 now, right? Yes. Thank you. Okay, in the Veteran Classic, this is a fairly new division. The idea is because the Classic division is intended to be an entry-level division, and because we have a lot of teams staying in the Classic division, we have essentially said, we're going to start a new division called the Veteran Classic division. If you are running the same basic structure, of course you can do upgrades and things like that, but if you're running the same basic frame, you're not rebuilding a completely new car, and you've raced that for 2 years, so for the 3rd year and on, you'll be bumped up to the Veteran Classic division. And this allows new teams to have opportunities to place well in the Classic division, coming in new, and the experienced teams can compete with one another and do the optimizations. So that's the Veteran Classic division. Now, if you've been doing solar car for a while and you want to start exploring new things, this is where the Advanced division comes in. We now allow you to get more efficient solar cells. You can play with hub motors. You can play with different battery chemistries. So most of the cars that are in that division run some type of lithium technology, lithium polymer, that type of thing. We've also had teams experiment with university-built molds. This is the idea that you would create a composite body, sometimes composite framing as well, for your solar car. And the use of a university body mold is that they've already done the aerodynamics for you. Universities have a lot more resources. They're looking at more million-dollar budgets type of thing for some of them. So they probably run their model through a wind tunnel or sorts. So if you were to use one of those, we say you got to be bumped up into the advanced division. Why this happens, also why these university molds become available, is because the American Solar Challenge, the college race essentially, they continue to change their rules. And so the universities have to build new molds to form, to meet the regulations of those new races. Our regulations are more in line with what they used to have. And so universities would love to give away their molds so that they don't take up space. So that is an opportunity to experiment if you want to go that route for teams that have been in it for a while. The advanced division champion from last year is the Walnut Solar Car team. You can tell it's not a university mold, but it does use lithium batteries. Okay, the electric solar division is also a fairly new division. We've had it for a few years. Sorry, the efficiency has the same typo as 19%. Basically, it's essentially classic division rules with some changes. Why we started this to begin with was a thought from Ford about trying to have a concept of charging stations, that you wouldn't necessarily have to have all your solar inputs and things like that with you. You would drive up to a charging station, swap your batteries, and go along. I would imagine that's really the future of commercial electric vehicles. I doubt that we will see like solar panels mounted on a car, but the electricity that's used in the electric car could be generated by solar in some type of fixed installation. And that's what we're trying to do here. So it's classic division rules. So no hub motors. It does require 2 people in it. So you can see here, there's the driver and what we call the navigator, and there's specific responsibilities for the driver versus the navigator. The battery packs are a little bit smaller. In the other divisions, you are limited to 5 kilowatt hours of battery capacity. In the electric solar power division, you have two kilowatt hour packs, and so it will be smaller. And of course, we talked about separate charging stations. Because we're coming up to a cross-country race, let me take a few moments to talk about what this means. On the track, as most of you guys may know who have been here on a track race, these charging stations are fixed in place at the Texas Motor Speedway. At the beginning of the race, you drop them off, you set them up, that's where they're going to be. And that's sort of intended to be simulative of a fixed station charging station. Well, in a road race, you can't do that. We can't set the charging station in one place. So what's going to happen is those participating in the electric solar division will have a separate charging trailer that you would bring along the race route with you. And to come when you see the policies and procedures document for a cross-country race, you'll see how the charging station travels along with the solar car caravan, when you can charge and the like. So watch out for that. Okay, so getting that out of the way and just giving some context as to divisions, let's talk a little bit about building. And so the very first thing to get your car rolling is to get a frame together, right? And so we'll talk about what type of materials we'll use to build the frame. We'll talk about the roll bar and crush zones, suspension and steering, and wheels and brakes. Okay, so the very first type of material for your frame that's going to be the absolute easiest thing to do is the use of mild or carbon steel. It's something that my first year teams, when I was back in '97 and when I started the Walnut Solar Car team in 2005, that's a picture of the Walnut Solar Car team in 2005. That's what we started with. We really like mild steel because it's very inexpensive. We're talking about on the order of less than $1 a foot. So it's very easy if you make mistakes, if you want to change your frame in any way, you just go and chop it out, put new steel in there, you're done. I will share a story that way back in 1997, my very first year in the race, we built a solar car. We finished in March to do some testing. Got it out on the road. Could not drive fast enough. It just was not the performance we were looking for. So what did we do? We got home, chopped up the car, rebuilt the frame, put all the same components back into the frame with a different design, and we went. And we were able to do that because we had regular mild carbon steel we just put together, framed it up. We're done. Now, there is a problem with mild steel, and it's very heavy. This car in 2005 used to have a different name. I don't even remember the name of it. When we got to the race, it got rechristened El Tanque del Sol. It was a tank. It was, I think one of the judges also talked about it. We heard from people, yeah, that's a tank. I don't remember how much that weighed. It could have weighed a ton. It really could have weighed a ton. But, and that's the problem. In my philosophy, first year team, the whole idea is overbuild. Make sure that it works. If it doesn't perform as well, that's okay. You got a car on the road running. Then you have your future years to optimize, right? And so, like Joel was saying, the first year, his goal was pass scrutineering, get a lap, right? So if you use this type of thing, just know that your performance isn't going to be the same as like, experienced classic division or veteran classic division, but you get your car on the road, you learn how to build things quickly, okay? So moving on, the next step up would be chromoly. Based on the discussion earlier, I suppose it does not require TIG welding. I put that up there because it is typically a thinner wall material, and so it does require a little bit more expertise in welding. Now, I have to admit that I have no experience with chromoly, so I will yield to those who are using chromoly to share, why they use it. It is a bit more expensive though in terms of getting it. So I would suggest that you at least mock up what you want to do and then move on from there.
Chromoly is amazingly flexible. So when you build a chromoly frame and you sit in it, it sags down quite a bit. So it's almost not worth it. Again, you build it up and the weight builds up, and you might as well use something like aluminum.
Shannon, maybe you can share some experience.
All I was going to say is
we couldn't proceed in this solar car challenge without talking about titanium. Let me caveat to say, we in no way would recommend use of titanium in this race. However, there is a team, this is the picture of the team from Indiana way back, late 90s, early 2000s, I believe, where they used titanium, and it was it's very light, it's very strong. It's just that it's very expensive, and if you were to have to change anything in any way, you really couldn't do it on the race. And we hear the story about the rear shock mounts being broken on this car and having to do some very inventive things along the way during the race to fix that. We just put in here for completeness purposes, just because, well, we've had history of a team doing that. It was quite a neat car too.
When you talk about the other team using it, they were one of the host teams for that particular race, 2001, going to Indianapolis. So a home team bringing their car home. Because they used titanium, they could never get their car running. It was horrible for them to have to carry their car on a trailer across a finish line with a crowd of home people that ready to see it drive across. That's not what you want to have happen.
Has anybody tried composites yet?
Oh, that's coming up.
Okay.
So, some of the places in terms of sources, in addition to the source paper, this is some places you can get some of that material. Composites, here we go. So there are teams, a lot of teams who use composites are using it based off of university molds. There are some teams that make their own molds and do it. Of course, it is very light and stiff. It is expensive, supposedly. I think the amount of material that you have to put in and sandwich things together does cost a bit. I think the key part of the composites is you need to plan, because once you start laying down the pieces of composite and you start putting resin on and all that stuff, if you make a mistake, you're tossing it and you're starting over, and that's where your expenses come into. Mark Westlake used to talk about this, and I think you do too. You really have to do a complete dress rehearsal on the day that you're going to be putting the resin in, because you have a certain limited time to get everything done. And so if everyone does not know what they're doing, if you go, oh wait, I forgot to do this, you're not going to get the process done in time. So that is the concern. I also have to say that I have not done this. This is a little beyond my level of expertise, so maybe I can yield the floor to Lee a little bit to talk about that.
You got expensive and needs careful planning, and they're related, because I probably don't need that. What? Oh, they can't hear?
No.
Okay. Sorry. The expensive part and this one.
Start out. Check.
Check. The expensive line and the needs careful planning line are related, because every team that starts with this usually makes a mistake, and that's the problem. You have half a car that's just crooked and soft here and the wrong shape there, and you throw it out, and you should throw the next one out perhaps. So that's the expense. If you can plan ahead, like William mentioned, lay it out very carefully, and the students that are going to show up, and you have plenty of work detailed to paint or however you put out the epoxy. If it's summertime, if for some reason these things are always built on the hottest day of the year or the coldest day of the year. And the hottest day of the year, the stuff sets up in 20 minutes. The coldest day of the year, it never sets up. You wait days. So careful planning is the key to beating the expensive part. And anybody has questions on composites, I'll be more than happy to answer your questions. I'll be up here.
I'll go to it. In addition to the planning, designing the composites is non-trivial, and it's not a skill set a lot of people have. Lots of people know how to work with with steel, but we've had several cars show up that were not structurally sound because it looked good, and there were some very pretty cars, but they just weren't strong enough. So if you're going to go that way, make sure you seek out expertise, especially if you're getting a college mold. Pick the brains of people who did it, because it's very important.
I will say, though, that we do have materials on our webpage. Now my mic is off. Anyway, there are materials on our webpage and on our YouTube channel that talk about how to lay up composites. It's, I think, a video by Lee that show you in, in a very short period of time, a time-lapse thing of how to lay up composites. So that is a resource if that's something that you want to consider. There's a particular place I was standing over here.
Stationary match.
That's all right. Well, this one's.
It's
okay. I think well, wow. Okay, that works. I just need to touch the other mic. That's what it is. Express Composites is the place that Mark Westlake goes to get this material. So that's something that you want to explore. Mark isn't here. Mark is the advisor mentor for the St. Thomas Academy Experimental Vehicle team. He has always said that if anyone has questions about how to do composites, he would be definitely open to helping. And so if you want his information, you can come talk to me about that. Okay, roll bar, roll cage, and crush zones. These three structural components really get teams in trouble in terms of proper design. The whole idea is you want to have, just like in a race car, parallel structures, something that's strong, close to the driver to protect from impact from anything that's going to penetrate into the driver's space. And you want to have an outer, lighter structure to absorb the impact and deflect that away from the driver. That's really the intent. That's what we're trying to do. Okay? And so when we talk about the roll cage, we're talking about the inner part, the strong part of the car that protects the driver. That roll cage needs to encompass the entire driver and be an integral part of the structure, obviously, because you need to make sure that no impacts can penetrate into and towards the driver. Okay? If you have a design in which you have a driver that's in the same plane as a body panel or a solar panel, for example, where a front collision would drive that back, this roll cage must deflect that away from the driver so that he essentially doesn't get decapacitated. Okay? Decapitated, sorry, decapitated. Decapacitated as well, but decapitated. So, and we do want to have some space, 5 centimeters, not much, but some space around the driver so that in case there is some movement, some impact into the roll cage area, you're not right next to there. And there are some minimum diameter and mold thickness rules that I would recommend you look at in terms of rules.
Can I go back? It's rule stuff. I'm going to do this. The deflecting the array is. Thank you. Does that work? Okay. The deflecting the array rule is critical anytime you have the driver's head sticking out through the solar array or through another body structure that can be pushed into it. And I can say that teams that do not make an effort to comply with this rule will not pass scrutineering and will not be allowed on the road. So I can't stress this enough because teams overlook this at times. There has to be something there to protect the driver. That is absolutely critical. Because, you know, oftentimes we will bolt things onto the body shell, especially if you have a clamshell type car, which is common with composites. People will bolt things on there. It can shift if the car hits something. And there's got to be something there to protect the driver. And that's part of the job of the roll cage. Anyways, that was it. I just wanted to emphasize it because it is something that can prevent a team from participating in this event. So.
Sorry, we're doing some AV stuff back there, so I'll just do that. Question? So what I would suggest is, so the roll bar rules are, are a particular rule, has particular strength properties, and there is a provision in the race rules to have a waiver to those regulations. And so in that particular case, we would ask that you would draw up what you intend, provide the engineering analysis to show, yeah, this is in line with the spirit of what we're trying to do, and then the staff can then evaluate things and get back to you on a decision on that.
Waivers are not easy to get because you are having to do a proof there, an engineering proof that what you're proposing is as good or better than what the rule requires. And that requires some substantial supporting to go along with it. And we do this because we come up with a standard of what we think is safe, how much distance between you and that roll bar, what size roll bar, that kind of thing. So for a variance there, it's not a, well, can it sort of work? No, it has to be as good or better.
Yeah, and I want to stress that in terms of the waiver, since we're talking about that. Yes, we have a waiver provision, but a lot of times we don't get the level of detail that we need to evaluate whether or not to issue a waiver. And so if you were to even try to ask for a waiver, you're going to need to provide us not only detailed plans. So a lot of times we'll just say, oh, a sentence or two, we plan to do this. Well, we don't know how it's mounted in the car. We don't know what other surrounding materials are there. So you really will need to give us, here's a drawing, here's pictures of what we intend to do, here's the engineering analysis that shows, yeah, there's some equivalent strength here. So that's what I'm saying.
For instance, just this year, we had a group out of Arizona that wanted to build a car out of wood, and wanted to know if they could have a roll bar made out of wood. And we had to come back with the same kind of response. You've got to be able to demonstrate and show to us that it is just as good as a roll bar requirement set out in the rules. And eventually they realized they couldn't do that. Same thing was true with composites. You've got to show engineering-wise, if you're going to try to do something with a composite roll bar or roll gauge, you're going to have to show us it's going to be just as good. That's a hard thing to do. But it's all about trying to keep you safe. We're not trying to be mean or over-obstructive here, but we're trying to maintain a safety level which we think will help keep your drivers safe.
As we talk about the roll cage in response to composite material, actually, let me talk about it in the roll bar stuff. This particular picture is really intended to show the necessity of a roll cage and roll bar. This was an experience with the St. Thomas Academy team at the Eco Marathon. And I think it was this previous year where they're driving in the competition and their car actually, oversteered and rolled over. And so without a protective structure like this, that driver could have been in trouble. We've had certain other instances as well. Back in '97, we had a car crash into a guardrail as opposed to an oncoming truck. And it's these type of safety structures that help protect the driver. On that instance, the driver just walked straight out because there was sufficient crush zone and roll cage material to help. Okay, the roll bar is essentially part of the roll cage, but has different requirements. And you'll see in the rules there are 3 specific sections: a roll cage section, a roll bar section, a crush zone section. So in the roll bar, that's essentially this hoop that's above the driver's head. Okay, and the idea is that when if the car flips over, that's what supports it and prevents a team from, basically getting impacted on the head. Okay. There's some other views. So I guess I don't have the regulations in here. In terms of the roll bar, the idea is it's fixed into the structure of the car. It's of a particular outer diameter distance and a particular thickness based on material. It does need to be mounted at multiple points, because if you mounted it straight up and attached in one point, it could potentially shift based off the impact. So we do require you to mount it and weld it on multiple points. On a composite body design, we're saying that unless you can prove otherwise with a waiver, you're required to have a metal roll bar structure with all the requisite outer diameter and wall thickness. And so for those composite cars, you're going to have to find a way to, mount that into your composite body in a way that is structural, and that's difficult to do, but it's possible. So it's something to consider when you think about composites.
I just want to speak to that a little bit, because while we're talking about the materials that we're using, you definitely want to make sure that you're following these requirements, but equally as important is how you're applying those materials. So if you're using a appropriate piece of tubing that's 5 centimeters, if you don't weld that appropriately to the frame,
do not meet if certain drivers don't meet the requirements, they just can't drive, and you don't want to design your car in that way. This is a crush zone of a car that was before. So you see there's no crush zone by the driver's head. That you'll have to put something there now. But you can see that there's a fairly wide crush zone, somewhat substantial, but still able to give because there's some spacing here for the impact. And then there's the roll cage on the inside. And so that's an example of something we would want to see. Okay. Here's another example, crush zone on the outside, front and back. And then I'll stop here. We'll talk about wheels and brakes and all that stuff at the next portion of this lecture.